Hello, I'm Tree Varghese, and I want to talk about multiple sclerosis. This is a comprehensive review of current treatments and for future trends. Multiple sclerosis is an autoimmune disease that affects the neurons of the central nervous system. The immune cells attack the myelin sheath of the axons of the neurons in the brain. A myelinated axon allows for increased neural conduction, and so if a damaged neuron, if there is a damaged neuron, there will be decreased or slowed neural conduction, which results in the symptoms seen in multiple sclerosis. These symptoms include vision changes, cognitive changes, loss of balance and coordination, and decreased function. It is a disease that recurs, and depending on which stage of the disease that a patient is in, it will have various treatments. My question is, what barriers do we face in finding a cure for multiple sclerosis? There was a lot of research already done into multiple sclerosis and how to treat the disease. Some treatments relate to disease-modifying treatments that try to slow the progression of various symptoms. Other articles focused on the patient perspective and the difference between a patient's understanding of multiple sclerosis and its disease progression and the healthcare provider's understanding of the disease progression. This will lead to a difference in treatment adherence as well as compliance and overall awareness. The potential for stem cell transplantation for treating multiple sclerosis has been looked at as well, and that's what I want to focus on. Both autologous homeopathic stem cell therapy and autologous mesenchymal stem cell therapy have been looked at as potential ways to treat multiple sclerosis. Fortunately, neither one can cure multiple sclerosis as of now, and there are several risks to the patients from going through these routes of treatment. For example, autologous homeopathic stem cell therapy requires chemotherapy, and it is very painful and exhaustive for the patient. While autologous mesenchymal stem cell therapy does not require chemotherapy, it is only offered as a clinical trial in almost every country. Autologous homeopathic stem cell therapy is offered in several countries as a treatment, but it is not available in the US. Both stem cell therapy and remyelination are treatments geared towards finding a cure towards multiple sclerosis. The current treatments are disease-modifying behaviors and treatments to slow or improve disease progression so that people can live without the disabilities that this disease causes. However, we are trying to find a way to reformat the immune cells in the body so that eventually the immune cells will stop attacking the neurons. And remyelination also looks at a way to regain function for any lost functions from the disease. Combining these past research with current trends will help break down the barrier for finding a cure for multiple sclerosis. And that is what my research hopes to achieve, including in this presentation and the future paper. Thank you.
You want to stop sharing and share your experience?
Yeah. I really appreciated the professor's help in understanding various aspects of neuroscience, as well as how to properly conduct research and write about it. I enjoyed the class style and and the support that it gave me while I was going through the process, including the one-on-ones and any additional help that was given.
Excellent, thank you. Professor Varghese, questions for Teresa?
Good job, Teresa. So I know that you have, with respect to what you presented, I know that you have a lot more data in there as compared to what you have put, actually showed today. So just a couple of questions for you. One, what does exactly myelin do? What does myelin sheath do?
I'd love to tell you. Okay, so myelin sheath is actually like the cell that wraps around the axon of a neuron, and it acts as like an insulator. So neuronal conduction actually works by the movement of ions through channels, and it allows like a charge to run through the axon and affects the next neuron. But in myelin sheath, it like has underneath the myelin sheath, there are no ion channels. And so it only goes in between the gaps of the myelin sheath. And that's how it travels through that particular type of neuron. And if you take away the myelin sheath of an axon, since there are no ion channels underneath, it won't be able to travel as efficiently. And in fact, like myelinated axons have a faster neuronal conduction than non-myelinated axons.
Very good, Teresa. That's it's good to know all the fundamentals, because that will help you a lot in the future as well. Good presentation, and I hope that you'll continue to expand upon this research. Also, best wishes for all whatever you're going to do in the future.
Thank you. Should I answer the questions in the chat?
Yes, please answer the questions in the chat. You can turn off your video, and great job. A big round of applause to Teresa. So we are here, we're a community, and I want each and every one of you to be there for each other and uplift each other. So please stay till the end and look at others' presentations, learn from them, and ask questions. Okay, it's a great job.